Hola a todo el mundo, vamos a revisar cómo está esto. No hay nadie y estamos excelentes. Bueno, hola a todo el mundo, si les gusta lo que ven, déjenme un like, compartan, suscríbanse, revisen todo lo que promuevo debajo de la descripción. Debajo en la descripción está cómo ponerle subtítulos al video para ver este video de pandas. También está la lista de reproducción y también está las notas de este archivo. Bueno, entonces, primero yo le di entorno de ejecución, ejecutar todas para que, para que el pedacito de Python que hicimos, este Python que hicimos, descargara el survey y lo ejecutara todo y siguiera donde estamos. Entonces, sigamos. Vamos a hacer esto 45 minutos. Sigamos.
Series. And I said that a data frame, and that's important. So let me go over that one more time. So we can see that a data frame here is two-dimensional because it has rows and columns. So we can see here that it has first name, last name, email. Now, whenever we access just the email,
Sorry,
then we can see that we get all these emails here. Now, this is a series. And I said that a data frame basically is a container for multiple series objects. So we can think of this email column here as a series, this last column here as a series, and this first column as a series. And also we can see where we printed out this series here for the emails, we can see that this series also has an index as well, just like our data frame did. So this index is over here on the left, the 0, 1, and 2. Okay, so we can access a single column of a data frame like we're accessing a key, just like we did here in this cell. But you might also see some people use dot notation to do the same thing. So you might see some people do it like this. So they might do df.email. And if I run this cell, then we can see that, let me get rid of this cell here. And just so we can compare these two, we can see that this gives us the same thing. Whether we access this like a key or whether we use dot notation, this returns the same series object of the email values. Now, whichever way that you want to do this is really just a personal preference. I actually prefer the first way of using the brackets, and there are a couple of reasons that I prefer to use that over dot notation. First is that I like using the brackets because there's a chance that one of your columns is named the same thing as one of the attributes or methods of a data frame. And if that's the case, then using the dot notation might give you some errors. So for example, if a data frame has a method called count. So if you had a column named count and you were trying to access that count column using dot notation, then that's actually going to access the count method from data frame instead of that count column. So that actually wouldn't work how we did it here. If you wanted to access the actual column called count, which we don't have one in this specific data frame, but if we did, then we would have to access it like this. So that's kind of why I prefer brackets. So I'm going to be using brackets throughout this series, but I wanted you to know about dot notation because if you're working with other people using pandas, then you might see them access columns in using dot notation. So you need to know that it's at least a possibility. And again, that doesn't mean that they're doing it wrong. It's just a personal preference. I just prefer using the brackets. Okay, so I said that data frames have a lot more functionality than what we saw using, standard Python. So let's look at some other stuff that we can do here. So let's say that we wanted to access multiple columns. Now, in order to access multiple columns, we can use the bracket notation and pass in a list of the columns that we want. So if I wanted both the last name and email columns, then we could say df and use our brackets just like we saw before, But now I'm going to put in a set of inner brackets here as
Genial.
a list of columns that I want
Esto
to
completa
access.
lo más de
So
buena.
for the first value, I'll put last for the last name. And for the second value, I'll put email for the email. So if I run this, then we can see that now we have a data frame returned here of the last column and the email column. Now, I want to emphasize again here that I passed a list inside of these brackets here. So there are two pairs of brackets. You can't leave off the inner brackets because you'll likely get a key error because pandas will think that you're passing in both of those strings as a single column name. And another thing that I want to point out here is that now that we're getting multiple columns, this can no longer be a series because remember, a series is basically a single column of rows. So when we get multiple columns like this, it's just returning another data frame. And in this case, it's a filtered down data frame with just these specific columns. So we filtered out the first name column here, and we just have the last and the email. Okay, so that's how we get a specific column or multiple columns, and we can slice these as well, similar to how we slice a list. But I'll show that on our larger Stack Overflow data set here in a second. Now, if you have a lot of columns and want to see all of them easily, then we can just grab the columns specifically by saying df.columns, and we can run this, and we can see here that this gives us all of our columns here. So our columns are an index of first, last, and email. Okay, so now we've seen how to get a column, but how would we get a row? So in order to get rows, we can use the loc and iloc indexers. So that is loc and iloc. So let's take a look at these. So first, let's take a look at iloc. So iloc allows us to access rows by integer location, hence the name. Iloc is integer location. So if I wanted to get the first row, then we can just say df.iloc and then use brackets here to, since this is an indexer, use brackets and pass in a 0, and that will give us the first row. So if I run this, then we can see that the first row has a first name of Corey, last name of Schaefer, and email of corymschaefer@gmail.com. So what that did is it returns a series that contains the values of that first row of data, which, like I said, is the first name, last name, and email of the first person in this example. And again, we haven't discussed indexes yet. That will be in the next video. But the index here is the column names so that we know what those values are. So up here, our index was 0, 1, and 2. But whenever we're actually accessing a row, it's going to set that index to the column name so that we know what those values are. Because if this just said 0, 1, and 2, then we might not know what these are. And just like when we selected multiple columns, we can select multiple rows as well by passing in a list of integers. So if I want the first and second row, then we can just say, and again, this is going to be a pair of brackets within these brackets because we're passing in a list to our index here. And I'm just going to pass in a list of 0 and 1. So if I run this, then we can see that now we get the first two rows of data. And again, be sure to pass in an inner list inside those brackets so that it does what you expect it to do. And also, we can see that now we're getting a data frame with these multiple rows. Now, with these iloc and loc indexers, we can also select columns as well. And that is going to be the second value that we pass into these outer brackets. So if we thought of iloc and loc as functions, then we can think of the rows that we want as the first argument and the columns as the second argument. So let me show you what this looks like. So here we have our inner bracket. Those are the rows that we want. But now, after that list, we can put a comma, and now we can specify the column that we want. Now with iloc, we can't specify an actual column name because these use integers, integer locations. So these are for integers only. So remember, our first name is the first column. The last name is the second column, and the email is the third column. So if we wanted to grab the email address of the first two rows, then we can grab the column at index 2. which will be the third column since all of these start at 0. So if I was to pass in a 2 here and run that, then we can see that now we get the email addresses of these first 2 rows. Okay, so that's iloc. So now let's look at loc. So with iloc, we were searching by integer location. With loc, we're going to be searching by label. And when we're talking about labels for rows, these will be the indexes. And again, we don't have custom indexes right now, so this index is just a default range of integers. So at the moment, this will somewhat be similar with iloc, the iloc indexer, but we'll look at uses or use cases with loc with actual labels in the next video when we cover indexes. So real quick, let's look at our entire data frame again. So I'm just going to print that out down here. So like I said, over here on the far left, these are our indexes. So these are the labels for that row. So if I want the first row, then by default, this just has a label of 0. So I can say df.loc and pass in a 0 there. And if I run that, then we can see that we get that row with that label of 0. And again, I know that that looks similar to iloc at the moment, but we'll see how to use indexes with labels in the next video. And just like with iloc, we can also pass in a list to specify multiple rows. So if I wanted the first and second row, then just like with iloc, I can pass in an inner list here. So let's say that I want the first row and the second row. So I'll run that. We can see that now we get the first and the second row. And again, now we can see that we are getting a data frame back with now that we have multiple rows. And just like with iloc, we can also pass in a second value into our indexer to select specific columns for these rows. Now with iloc, we used integers to select the columns, but now that we're using loc, we can use labels. So if we want the email column of these first 2 rows, then now we can just pass in a value of email. So if I run that, then we can see that now we get the email value of these first 2 rows. Now, I didn't show this with iloc, but we can also pass in a list for the columns as well. So if I want the last name and the email for these rows, then instead of just passing in a string as this second value here, then we can pass in a list of strings of the columns that we want. So I'm going to wrap this in brackets here. I know that this can get a little confusing with all these inner brackets, but let's say that we want email and we want last name. So if I run this, then now we can see that we got these specific columns here, email and last name, for these specific rows, the row with label 0 and the row with the label of 1. And also notice that the columns display in the order that we used in our list up here within loc, which is a different order from our original data frame. So up here, it's first, last, email, but we asked for email and last, and it gave us back in that order of email and last. Okay, so now that we've seen the basics of grabbing certain rows and columns from a small data set, now let's go back to our data set from the last video and see how we grab some rows and columns from the Stack Overflow data set. So I'm going to go over here to back to our Pandas demo here. And again, just a quick overview of the data that we have here. We're importing Pandas. We have df as our main survey results here, our schema df as our schema results. We are setting some options here. This is what our main data frame head looks like, which is the first 5 rows. And then this is what our schema looks like. So I'm going to go down below our schema here. And now let's mess around with this a little bit. So let's go over a bit of what we learned and pluck out certain rows and columns. But first, let's see how many rows and columns that we have in this data frame. Now, we saw a couple of different ways to do this in the last video, but the easiest way to do this is to use the shape attribute. So if I say df.shape and run this, then we can see that we have 88,000 rows and 85 columns. So let's grab all of the responses for the hobbyist column. So again, what I'm trying to do here is, if we look at our main data frame, I want to grab all of the responses for this column right here, hobbyist. Okay, so how would we do that? Now, if you remember, if you want to see what columns are available, then you could just say df.columns to see all of these. We can see that these are kind of long. We have 85 here. But here we have hobbyist, which is the one that we want. And that is the question where people answered if they code as a hobby or not. And in the next video, we're going to cover indexes. I'll show how we can, search a schema data frame to find exact questions so that we can see what questions are what specific columns in the data frame. But right now, let's just grab those hobbyist responses. So if you remember from that small data set that we just saw, in order to grab that hobbyist column, we can just access that like a key. So if I say df and then pass in hobbyist there, then we get a series of all of those responses. And luckily that doesn't display the entire 89,000 rows in our browser here, but we do get the head and the tail of that data to get an idea of what those responses look like. Now, real quick, let me show you something that we'll cover more of further into the series, but I want to give you an idea of how powerful something like Pandas is. So let's say that we wanted to know how many of these responses were answered yes and how many were answered no. Now, if we were using regular Python, then we might import the counter class or write a quick function or a loop to do this. But Pandas has so much of this stuff already built in. So to get the count of unique values in this column, I can just use this value counts method to calculate this. So right up here, I can just tack on a method of value underscore counts. Now, again, this is going to be for a future video, but I just want to give you an idea of what Pandas can do. So whenever I add this value counts method, we can see that out of this series that we returned here for all of our answers for this hobbyist question, the value counts are 71,000 people said yes, they do code as a hobby, and about 18,000 said no, they don't code as a hobby. And again, we'll cover more of this in future videos when we learn more about analyzing data in depth. But I wanted to give you a quick taste as to why it's beneficial to even learn Pandas like we're doing here. It makes this type of stuff really easy, and we could go further and plot that out and everything. Okay, but with that quick sidetrack out of the way, let's keep going and go over the other things that we learned earlier. So we got a column here. So let me get rid of that value counts. So we have our column here. So now let's grab a specific row and a specific column. So let's grab the first row, and we'll also grab that same hobbyist column for that row. So how do we grab rows? So remember, if we want to grab rows, that we use the loc or iloc or indexers. So I'm going to go ahead and use loc because remember that that's the one that allows me to use labels. And I'm going to use a label instead of an integer for the hobbyist column name. Now again, since we're just using a default index, and we can see the indexes here, 0, 1, 2, 3, 4. Since we're just using a default index instead of a custom one, our current labels for our indexes are just a range of values from 0 to 88,000 something. So in order to get the first row, I can say df.loc and pass in that label of that first index, which in this case is just a 0. And these are all of the responses from the first respondent. So this is one person's entire survey results here. Now, if we wanted to see their results for just that hobbyist question, then remember within the brackets here, I can pass in a second value for the columns that I would like. So if I pass in hobbyist, then we can see that their answer to that whether they code as a hobby is yes. And also, like we saw earlier, I can also pass in a list of multiple rows or multiple columns to get the exact rows and columns that we want to see. So to get the first 3 responses for the hobbyist column, then instead of just passing in a single value here, then I can put in some inner brackets here and pass in a list of multiple rows. So if I pass in a list of 3 rows here and run this, then these are the first 3 results for that hobbyist column. Now, one thing that we haven't seen yet is that we can also use slicing to grab multiple rows and columns as well. Now, if you're familiar with list slicing, then this is pretty much the same thing. The only difference is that our last value is going to be inclusive, at least with loc. So if we wanted the first 3 rows, then we could say that we want from 0 and then slice to the index of 2. And if I run this, whoops, and I accidentally made a mistake here. Actually, whenever we're using slicing, we do not wrap these in brackets. So I'm going to take that out. So for our first value, we're just saying we're no longer passing in a list of values. We're just passing in this slice of 0 and then colon 2. So if I run that, then we can see that now we get the same result that we got before. And we can do this with the columns as well. So right now we're only getting the hobbyist column, but let's go back and look at our columns and see what columns come after the hobbyist column. So up here, these are all of our columns here where we printed them out. So let's look at a few columns after hobbyist here. So we have open sourcer, open source, employment. So let's say that we wanted to get all of the columns from hobbyist all the way up to this employment column. So to do that, I'm just going to copy.
¿Qué le pasa al internet? ¿Será que me están atacando? Se supone que está bueno. Bueno, yo voy a seguir a ver si se cae o algo o qué pasa.
Copy that. We can come down here and we can just pass in a colon and then employment, and that'll do a slice from hobbyist to employment. Now, I also want to point out that this is the reason that slicing is inclusive for these values, because imagine how much of a pain it would be if we wanted all of the columns from hobbyist to employment, but the last value here wasn't inclusive. And we had to come up here and say, well, if I want from hobbyist to employment, then I really need to pass in, hobbyist to country, and country's not inclusive. That would just be way too confusing. So it's so much easier for this to be inclusive here. So if you were wondering why they did that, then that's why they do it. So if I run this, then we can see that now we get these first 3 rows here. And for the first 3 rows, we get all of those responses for the columns of hobbyist, open sourcer, all the way up to employment. So now we've seen an overview of everything that we've learned about exploring our data frames and series objects so far, and how we can pluck some, basic information out of these. Now, there's still tons to learn about data frames and series objects, and we'll continue learning more about these throughout the Pandas series, since these two data types are the main data types that we'll be using in Pandas. So we'll be learning more about advanced filtering, queries, how to see which data type each column of our data contains, and a lot more. Now, before we end here, I do want to mention that we have a sponsor for this video, and that is Brilliant.org. Brilliant is a problem-solving website that helps you understand underlying concepts by actively working through guided lessons. And Brilliant would be an excellent way to supplement what you learn here with their hands-on courses. They have some excellent courses and lessons on data science that do a deep dive on how to think about and analyze data correctly. So if you're watching my Pandas series because you're getting into the data science field, then I would highly recommend also checking out Brilliant and seeing what other data science skills you can learn. They even use Python in their statistics course and will quiz you on how to correctly analyze the data within the language. Their guided lessons will challenge you, but you'll also have the ability to get hints or even solutions if you need them. It's really tailored towards understanding the material. So to support my channel and learn more about Brilliant, you can go to brilliant.org/CMS to sign up for free. And also, the first 200 people to go to that link will get 20% off the annual premium subscription. And you can find that link in the description section below. Again, that's brilliant.org/CMS. Okay, so I think that's going to do it for this Pandas video. I hope you feel like you got a good introduction to the data frame and series objects and how to navigate through some of your data. Now, like I said, there's a lot more to learn about these data types and some advanced filtering that we'll learn in future videos. So be sure to stick around for that. Now, in the next video, we're going to be learning more about indexes. So we saw basic default indexes in this video, but we'll learn how to set the index to specific columns and the benefits of doing that in the next video. But if anyone has any questions about what we covered here, then feel free to ask in the comment section below, and I'll do my best to answer those. And if you enjoyed these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching. Hey there, how's it going, everybody? In this video, we're going to be learning more about indexes. So we've seen basic default indexes in previous videos, but in this video, we'll learn how to set custom indexes and the benefits of doing this. Now, I'd also like to mention that we do have a sponsor for this series of videos, and that is Brilliant.org. So I really want to thank Brilliant for sponsoring this series, and it would be great if you all could check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. Okay, so I have my snippets file open here, or my snippets notebook open here, so that we can look at indexes using a simple data frame with a little bit of data. And then we'll see how to use these with our larger survey data set that we've been using so far in the series. So in these snippets, we have the same small data frame that we saw in the last video, where we just have 3 people with their first name, last name, and email address. And I have this data frame displayed down here at the bottom right here. So like I said in previous videos, our data frames have this thing on the far left over here that looks like a column without a name. And this is an index. So since we've just seen these default indexes so far, this is currently just a range of numbers that's basically an integer identifier for the rows. So this is a 0, a 1, and a 2. Now, sometimes it might make more sense to have a different identifier for each row, and that will basically be the label for that row. So it's usually unique. Now, Pandas doesn't actually enforce indexes being unique, and sometimes it won't be, but most of the time these will be unique values. So what might be a better index for our sample data here? Well, maybe the email address would be a good index for this data, since that's usually a unique value for most people. So right now, if I wanted to view all of the email addresses, then we could say df and access the email column. And we saw this in the last video, but we can see that it displays all of these email addresses. Now, what if we wanted to set these email addresses as the index for this data frame? Well, to do that, we could just say df.set_index, and then we can just pass in the name of the column that we want for the index. So if I run this, then now we can see that the email is on the far left and it's bold. And it actually does kind of look like a normal column because this index has a name. It has the same name as our column when we set it. So I want to show you something here. We can just set this index in this cell, but if I look at my data frame again, so underneath here, if I say df to print out this data frame, then we can see that our data frame didn't actually change. It still has the default index over here on the left. And that's because Pandas doesn't do a lot of these changes in place unless we specifically tell it to do so. And this is actually nice because it allows us to experiment without worrying about modifying our data frame in unexpected ways. So let's say that we actually did want to set our index to the email column and have those changes carry over into these future cells. So to do this, back up here where we said set index, we can just add in another argument here and say in place is equal to true. Now, if I run that and then rerun the data frame again, then now we can see that it actually did set that index and modified that data frame. And we can actually look specifically at that index just by saying df.index. And if I run that, then we can see that we have an index here, and it has the values as a list of what all the index values are. And it also tells us that the name is equal to email. Okay, so why would this actually be useful? Well, like I said before, the email address as the index gives us a nice unique identifier for our row. And remember in the previous video that we used .loc to search our data frame by label. Well, these indexes are the labels for these rows. So before, we just used the default ranged index, but now we can find a specific row by passing in that label. So if I say df.loc, this will be easier if we actually just look at an example here. If I say df.loc, before we were passing in a 0 as the label. But now I can say, okay, I want to see the information for Corey M. Schaefer at gmail.com. And then it'll come back and say, okay, that person has a first name of Corey, last name of Schaefer, and so on. So now we get the row for that specific email index. And like we saw in the last video, we can still pass in values for the specific columns as well. So if we wanted the last name, then I could just pass that in as the second value. So I'll just say I want the last name, and we can see that there we get Schaefer. Now we actually no longer have those default integers as our index because now it's using the email. So if I try to use those integers that we used before, so if I say if I want row of 0 using loc, then we're going to get a type error. And I get an error because it no longer has an index with that label. If you want to use integer location instead of labels, then you still have the iloc indexer available to you. And we saw that in the last video as well. So if I change this to be iloc instead of loc, then it'll still give us that first row. So that still works. Now, if you accidentally set the index and want to reset it, then we can do that with the reset index method. So down here, I will just say df.reset_index, and I will do an in place equal to true so that those changes carry over. And then I'll go ahead and print out that data frame. So if I run this, then we can see that now we're back to having that email as a column and the default range index. Now, if you actually know what you want the index to be when you're creating your data frame, then you can simply set it there instead of setting it later using the set index method. And we can do that as we're loading in data from a CSV or other source as well. So let me switch over to our other notebook here with the Stack Overflow data that we've been using so far throughout the series. And we'll take a look at some real-world examples of why using indexes is useful. Now, again, for those of you who have been following along with the series so far, this should look familiar to you. But if you haven't been following along, and this is the first video you've watched, here's a brief overview of what's going on. We are loading in Pandas here. we are loading in some CSV files here as well. And I have a link in the description section below to the data that we are using for these CSV files. And then we're also setting some options here in Pandas to display max columns to where we can see all the columns, and max rows to where we can see a lot of these rows. And then this is what our data frame looks like. These are just survey results from Stack Overflow. So far, if we look at our data frame here, in the series so far, we've been using this default index, and we can look over here and see that it's just this range from 0, 1, 2, and 3. Now, if we look at the survey response data, then it looks like they actually have a unique value per row within the data itself. So if we look at this respondent column here, this respondent column is actually a unique ID. So it's respondent 1, respondent 2, and 3, and so on. So really, we should probably clean this up a bit and just use that respondent ID as our data frame index. Now, we could do this just like we saw before by coming down here and saying df.set index and do it that way. Or we can do this while we're actually reading in the data by passing in an additional argument to the read CSV method. So up here where we loaded in the data, let's just add another argument here, and we will call this index underscore call is equal to, and now the name of the column that we want to be the index. And in this case, I want it to be this respondent unique ID here. So I'm going to say our index call is equal to respondent. I will rerun that cell. Now I'll come back down here and rerun our data frame head. And now we can see that this is cleaned up a bit because now we have this respondent as our actual index. So now these are the labels. So if you wanted the first respondent, then we could just say df.loc, and that is 1. So this is the first respondent there. Okay, let me delete that cell. Okay, so now let me show you a real world example of where I would use this. So if you remember from earlier in the series, we have our survey data that we can see here, but we also have another data frame that tells us what each of these columns actually means in the survey data. So let me display that data frame real quick. So for example, if I wanted to know what hobbyist meant, then we can look at our schema data frame here, and we can see that the answer that they or the answer on the survey, or the question on the survey for hobbyist, was do you code as a hobby? So when we see yes and no questions up here for hobbyist, they were answering the question, do you code as a hobby? So here's a question. What if I wanted to locate what a specific column meant without needing to search through this entire data frame manually? Well, in this case, we can simply set the column name as the index and use the .loc indexer. So I'll set this index up here where we loaded in the schema data frame. So let me go back up here to the top, and the column, we want this here to be the index because these are all unique values. So I'm going to grab the name of this column, which just so happens to be column, and then up here I will say that I want the index to be equal to this column of, actually let me get that within the string there, okay? Index call is equal to column, run that, and now let's rerun our schema data frame, and now we can see that that column is bold, so that is our index. So now we can use .loc to search for those columns directly. So if I wanted to see what the information for the hobbyist column was, then I could just say, let me scroll down here, I could say schema data frame .loc, and then we can just pass in the label of the index that we want. So if I wanted to see what hobbyist was, then we can see, oh, okay, hobbyist has the question text of do you code as a hobby? So let's go back to our survey data here and see if we can find a column that doesn't make much sense to us. So if I scroll through these here, okay, like what would this one mean? MGR idiot, okay? MGR idiot. So let me scroll down here, and now I'll paste that in to the schemadf.loc and rerun that. Now we can see that we get the information for that column. Now the text is actually truncated in Jupyter Notebooks by default, but we can We can change that setting if we'd like to see this entire question text, but I kind of want it on since we have so much data to display. But instead, if you want to see the full text for that question, then you can just access the data in that row and column directly by also passing in the column name into .loc as well. So just like we've seen before when we're using .loc, this is the row we want. So what column do we want? So we want
Bueno, yo creo que yo ya estoy cansado. Voy a descansar un rato. De pronto vuelvo, no, ya está muy tarde. Bueno, hasta luego. Tengan una noche genial. O no sé a qué horas están viendo esto. Si les gusta, déjenme un like, compartan, suscríbanse. Si no les gusta, déjenme un comentario, díganme qué puedo mejorar. Revisen todo lo que promuevo debajo en la descripción. Debajo en la descripción está cómo ponerle subtítulos a un video, y está la lista de reproducción de YouTube y está también este archivo donde estoy haciendo mis notas para que puedan aprender conmigo. Bueno, eso fue todo por hoy. Hasta luego.